Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic gravity. I know many of you guys have this topic coming up for exams, so hopefully this video can help you all in order to solve these type of questions. So this video will be highlighting the main questions related to the weight, mass, and gravitational field strength calculations. And time codes will be in the description box below so that you guys can skip to any questions you guys like. And if you guys want to change the quality settings of the videos in order to see the quality of the videos, if you guys want to change it and see the questions more clearly, you guys can do that in the YouTube settings just to see the questions more better. And by the way, this worksheet is taken from the site Physics and Math Tutor. I know many of you guys have already known about this site, but it's a good site for other subjects as well. And if you all have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so on 14th October 2012, a skydiver set a world record for the highest free fall from an aircraft. After falling from the aircraft, he reached a maximum steady velocity of about 373 meters per second after 632 seconds. Now we have to draw around the correct answer. We have to draw a ring around the correct answer to complete the sentence. This maximum steady velocity is also called as the terminal velocity. That's what we're going to do. So terminal velocity, what it means is that it is where the drag is equivalent to your, let's say, to the weight. So, similar to like when a parachutist guy is falling from the sky, his drag, which is the air resistance, is equal to the weight, which is caused by the gravity. So that's what terminal velocity means. All right, let's move on to the next question. Now the next question states that the skydiver wore a chest pack containing monitoring and tracking equipment. The weight of the chest pack was about 454 newtons. The gravitational field strength is about 10 newtons per kilogram. You have to calculate the mass of the chest pack. So what I would like you guys to use is a nice formula triangle, also known as the WMG. Now formula triangles are a very nice way to show the formulas. So what we're going to have here is that since they have given us the weight is to be about 54 newtons and the gravitational field strength is about 10 newtons per kilogram, the mass is going to be equivalent to the weight divided by the gravitational field strength, where 54 newtons in weight is going to be divided by 10 newtons per kilogram. That is going to be your answer. It's going to be equivalent to 54 divided by 10 to give us a value of about let's say 5.4. So 5.4 kg is going to be your answer for the mass of the chest pack. So I'm just using the formula here just in order to solve this type of question. All right, let's move on to the next question. Now, during his fall, the skydiver's acceleration was not uniform. Immediately after leaving the aircraft, the skydiver's acceleration was about 10 meters per second squared. Without any calculation, estimate his acceleration a few seconds after leaving the aircraft. You have to explain your value of acceleration in terms of forces. So, since leaving the aircraft, his acceleration should be about 10 meters per second. That indirectly tells us that it's going to be less than that. The value after a few seconds leaving the aircraft should be less than that. So let's say a rough about 9 meters per second squared. Now the reason why I'm going to say is that there would be some air resistance. Just like I said, when a parachutist falls, there are some air resistance when he falls, right? So there would be some air resistance, and which would result, let's say, result in a reduced resultant force. So this is going to be your answer for about, let's say, 3 marks. So you have to mention the value, and there will be some resistance, which will result in a reduced resultant force. That's going to be your answer for about 3 marks. Okay, let's move on to the next question. Now, without any calculation, estimate his acceleration 632 seconds after leaving the aircraft. Now, this is going to be after leaving the aircraft as well, but it's going to be 0. Now, the reason is because as the upward force, just like I said, which is going to be the drag or the air resistance, is going to be equal to the weight, which is in this case, like I said, the gravity, which is going to affect the parachutist in this case. So I'm just going to write this word nicely. All right, indirectly, and the resultant force, all right, the resultant force is going to be equivalent to 0. That's it. So that's going to be your answer for 3 marks. You're stating the value, you're stating the reason, and you're stating the resultant force of this specific thing. Alright, let's move on to the next question. Now, the next question states that the diagram shows a lampshade hanging from the ceiling. You have to draw an X on the diagram so that the center of the X marks the center of the mass of the lampshade. Now, on the center of the mass of the lampshade, so this is a triangle, so roughly about the center of X should appear to be on the continuum line of the flex and in the body of the lamp, which should be judged by the eye in this case. So it should be roughly about, let's say, I think somewhere here. This should be approximately. You guys can correct it if you guys know how to do it, but I think it should be roughly about the center of the ceiling. So I think it's somewhere between here. This should be your axis. All right, your X should land there, somewhere in the middle of that triangle. All right. Okay, now you're going to complete the sentence using the correct word or phrase from the box. A suspended object will come to rest with its center of mass, which is directly below the point of suspension. So I've talked about this in the previous video, the physics video. I think when dealing with let's say moments, levers, and gears, I've seen this question appear. You guys have to learn this statement by heart, like, just learn it. A suspended object will come to rest with its center of mass directly below the point of suspension. This point is really critical that you guys know this in your exam. Alright, let's move on. Next question is that the diagram shows equipment that a student uses to find the center of mass of a thin sheet of card. So you guys can see some bit of equipment there as well. So you can see a bus, stand, a regular piece of card, string, weight, strong pin. So they've given us a bit of sequences. So you have to arrange these sentences in the correct order to describe how the student can find the center of mass of the card. The sequence starts with the sentence D and finishes with the sentence E. So let's say the first sentence is that there are 2 holes that are made in the card, with each hole near to the edge of the card. So the next procedure is going to be the pen is going to be put through one of the holes. That's going to be happening next. So that's going to be B, and it's going to be held in the boss, right? So this is some good information that you guys can learn down and when dealing with this. And after that is that the weight is tied to the string, and then the string is then hung from the pen. That's going to be F. And the line is drawn from the card, marking the position of the string. That's going to be A. And you're going to have, this is going to be repeated using the other hole, so it's going to be about C. E should be the center of mass, is where the lines cross on the card, so that should be your value. So it's going to be D, B, F, A, C, E for 3 marks, alright? Okay, just learn these sentences in order. It's very critical that you guys learn this. 12 for 5 marks. Let's move on to the next question. Now, the next question we can see is that the diagram shows the forces on a small radio-controlled flying toy. You guys can see the lift force. Now, this lift force is considered as drag, and the weight is considered as gravity. And the mass of the toy is given. Now we have to use the same formula like you used in the previous question. You have to use WMG. Now in this case, you're going to calculate what W is. So W is weight, is going to be equivalent to the mass times the gravitational field strength. So here we have the weight is going to be equivalent to the mass of 0.06 kg times the gravitational field strength is given in the question itself. So you have 10 newtons per kilogram. Right, so this is going to be your value in this case. So your weight is going to be approximately 0.06 times 10 units per kilogram. That's going to give you a weight of about, let's say, 0.6 newtons. Yeah, it's going to be 0.6 newtons. That's going to be your weight in this case. So they would accept other units as well. You can mention the whole word units itself. So I'm just going to leave it as 0.6 newtons, and it's accepted. Now you're going to complete the following sentence by drawing a ring around the correct line in the box. When the toy is hovering stationary in midair, the lift force should be the same as the weight of the toy. So that's really critical that you guys understand that concept, is that when the toy is stationary, the lift force should be same as the weight of the toy. Right? So when the motor inside the toy is switched off, the toy starts to accelerate downwards. What does the word accelerate mean? Everybody knows that accelerate is either for, let's say, it's like an increased velocity. So what we mean is accelerate can also mean in terms of decreased velocity in this case, but in this case we're going to leave it as a changed velocity. You guys can also mention that it's a changed speed, or you guys can mention that's a change in direction. They allow faster, slower, and anything related to change in velocity or change in speed should be allowed. Now, what is the direction of the resultant force on the falling toy? Now, let's say the direction of the resultant force should be on the falling toy. Since the toy is falling, if a toy is falling, it's going to fall downwards, right? So the direction is going to be downwards. That's all. So you're just going to mention that it's going to be downwards. You can say it's falling, the toy's falling towards the ground, or you could just show the arrow itself downwards. That's all right, but technically just stick to words. It's much better in terms of dealing with these type of questions. All right, let's move on to the next question. Now, the next question is that you can see that a child stands a wooden brick on its end as shown in the diagram. The child then pushes the brick to make it tilt. How far must the brick be tilted to make it fall over? Explain your answer. You may draw a label diagram if you wish. So you guys can draw any diagram you guys like, but I'm just going to mention that how far must the brick be tilted. So in order to do this is that either the center of gravity has to be lowered or higher. So you can mention that, but you have to show that there should be a vertical line through the center of mass, which should be outside the baseline of the brick, or the line of action of weight is outside. So you can mention that the line of action, let's say the line of action of weight, line of action is just anywhere where the force acts. Okay, so the line of action of weight must be let's say is outside the base, is outside the baseline of the brick. All right, so how far should the brick be tilted? Maybe we can just draw a nice little hand there and just show that it should be tilted approximately, more force should be added there. Or you can mention that the brick, you can just draw a nice little diagram that the brick topples over. You should be getting some 1 mark approximately for that. But your main intention for this question is to show that the vertical line through the center of mass is outside the baseline of the brick. So it shows us that the idea that weight acts through or near the center of mass of gravity in this brick case. All right, let's move on to the next question. Now, the diagram shows a rectangle made out of a sheet of cardboard. You have to draw X on the diagram to show that the center of X is at the center of mass of the rectangle. So the center of X at the point is where the axis crosses in this case. So we're going to draw an X here. It's going to be where the axis crosses. Alright, next one. This is all center of mass questions. So drawing shows a car tire. Where is the center of mass of the tire? So it's approximately somewhere at the at the center of the tire itself. So you're going to say it's going to be where the, let's say, at the center of the at the center of the tire. That's going to be your answer for 1 mark. Explain your answer to B1. No, this is where, let's say, that where the axis, this is where the axis of symmetry of the tire that intersect with each other. So what I mean by this is the center of mass is somewhere where the axis of symmetry, where they intersect each other, and you draw an X here, that's your center of mass. So all we're doing is just explaining it in terms of words, is that this is where the axis of symmetry of the tire might intersect or cross each other. Alright, let's move on. Next question. Now the next question shows us that 2 children visit a playground. Diagrams shows this. The turning effect of the girl's weight is called her, let's say, it's called a moment. Alright, so you're going to circle that point. Point P is the axis of rotation. So point P, that's somewhere around here. That's going to be your axis of rotation. So you're going to say it's going to be rotation. Now, to make end A of the seesaw go up, you have to make the girl move closer to point P. That's the only way that it's going to happen, to make the seesaw, let's say, go up. Alright, so you have to make the girl moving closer to point P. Alright, let's say in another part of the playground, a tire has been suspended from the bar. And draw an X on the diagram so that the center of the X marks the center or the mass of the tire. So in this case is that the x should be marked between center of mass. You have to draw x here, so we're going to draw somewhere between here. X should be drawn in the center of the space that's enclosed by the tire. That's where your center of mass is going to happen. Now you're going to complete the sentence by using the correct word or phrase from the box. If the suspended tire is pushed, it will come to rest with the center of mass, which should be directly below the point of suspension. You guys see this point come again? It's very critical that you guys learn the statement is that center of mass will come when an object is at rest. Its center of mass will come directly below the point of suspension. So do remember that. There's some key facts in there. Alright, let's move on to the next question. Now the diagram or the drawing shows a plastic toy. You can see a little bit of T-Rex. I think this is the dinosaur. So explain the reason for your choice in part A1. So you have to draw an X on the diagram to show the center of mass. So it should be likely around center, likely position of the toy. Somewhere between here, this is where all the forces should approximately meet. I think somewhere around there should be the vertical line from X should be somewhere there between the two lines. That should be where all the mass is concentrated. Alright, so this is explain the reason. Like I said, is where all the mass seems to be concentrated. That's going to be your answer. Basically, center of mass just means it's a point where the center of mass may be thought to be concentrated. That's going to be your answer. Alright, let's move on. Next question. So just two ways in which the design of the toy could be altered to make the toy more stable. So what we can do is maybe increase the width of these feet. I think width is going to make it like better. Maybe you can make the legs more heavier so that it doesn't fall. So what I'm going to say is going to increase, let's say increase width of feet. We can also say make legs heavier. You guys can also mention other points as well. You can make the area of the feet base bigger. You can make the tail touch the ground or make the tail longer. Maybe that can help the T-Rex balance more better. Alright, let's move on to the next question. Now the diagram shows a passenger train on part of a roller coaster ride. Which arrow shows the direction of the resultant force acting on the passenger train is going to be this part where the resultant force is acting on the passenger train. Now for part of the ride, the maximum gravitational field strength acting on the passenger seems to be 3 times bigger than normal. Your normal gravitational field strength is about 10 units per kilogram. You have to calculate the maximum gravitational field strength that seems to act on the passengers during the ride. So you're going to use the same formula again, WMG, where the maximum gravitational field strength is going to be equivalent to the weight divided by the mass. So in this case, what we're going to do is we have the weight, the gravitational field strength. So actually you don't need to use this formula because actually if you see the question states that the maximum gravitational field strength acting on the passenger seems 3 times bigger than normal, so all you need to do is just do 3 times 10 newtons per kilogram to give you a maximum value of about 30 newtons per kilogram. So that's going to be your maximum gravitational field strength. It's going to be 30 newtons per kilogram for 1 mark. Alright, let's move on. Next question. One of the passengers has a mass of 75 kilograms. I think this is where you use the formula WMG. This is where you have to calculate the maximum weight of the passenger to have during his ride. This is that the maximum weight is going to be mass times gravitational field strength, where your weight is going to be equivalent to 75 grams multiplied by let's say what value we're going to multiply this by 30 newtons per kilogram. That is going to be your value on top. Okay, so you're going to have weight is going to be equal to 75 times 30, which is going to be 2,250 newtons. 2,250 newtons. That's going to be your answer for about 2 marks. Let's move on to the next question. Now the next question shows us that a student carries out an investigation using a meter ruler as a pendulum. We're going to draw in the diagram 1 and X to show the position of the center of mass. Since this is 90 divided by 2 is approximately 45, so it's going to be approximately here if you draw the axis of symmetry as well. All I did is 90 divided by 2 to give you 45, so somewhere roughly about there should be your center of mass. What is meant by the center of mass of an object is a point. I'm going to write it down. Is that the center of mass of an object I'm going to write it down here. By the way, the other parts, just X should be placed maybe approximately. Actually, no, it should not be 45. Roughly 45 should be the accurate degree, but we're going to place the value at X here. So at 50, it should be marked because it's half of 100. Alright, so what's meant by the center of mass of an object is going to be a point. It's a point at which the mass of an object, just write this down, guys. It's a point at which the mass of an object may be thought to be concentrated. So that's going to be your answer. Alright, let's move on to the next question. Now, the student taped 100 grams mass to a meter rule. She set up the apparatus as shown in the diagram 2. She suspended the meter rule from the nail through the hole close to one end so she could use the meter ruler as a pendulum. The distance D, so D represents the distance in this case, is the distance between the nail and the 100 grams. So we can see a nice little diagram here of the nail, a meter rule distance between the nail and the mass clamp stand. On diagram 2, a Y is used to show a possible position of center of mass of the pendulum. So the pendulum should be, the Y should be placed between the center of the ruler and the upper part of the mass. So of the pendulum, center of the ruler and the upper part of the mass, so somewhere between here. This should be approximately, I think, somewhere there. Okay, the student carries out an investigation. You guys can see there's a table where we can see the time for the 10 swings. Complete the table. So the mean value, in order to do this, you can use the space below to calculate this. So what we're going to do is we have these values, these test values, and mean time for one swing. That's going to be 16.5 plus 16.6 plus 16.5, all divided by 3, which is going to give you a value. I'm just using the calculator, guys. Do use the calculator for exams. It's really helpful when dealing with these type of questions. Alright, so it's going to give you a value of about 16.53. I'm going to leave it at 16.5. So that's going to be your mean value, 16.5. Your mean time for one swing is going to be roughly about, let's say, I think what we have to do is 16.5 divided by 10 something. Yeah, so it's going to have 16.5 divided by 10 to give you a value of about 1.65. That should be your mean time for one swing in seconds, 1.65. All I've done is rounded it off to about one decimal place. So you have 16.5 to be the mean value and 1.65 to be the mean time for one swing in seconds. Alright, let's move on to the next question. Now, the next question is where you have to use good English. I've seen most questions have this, so you guys have to use sentences. Do not use bullet points. Please do not use bullet points for this type of questions. Do write it in full sentences, like a paragraph, like how I've written here by typing it down. Alright, just to save up time. You have to describe how the student would carry out the investigation to get the results in table in part 2. So we have to explain how the student is going to get a table such as this. So, and you have to mention they have given you the points that you have to include. You have to include the apparatus. You have to include how she used it, and how to make the fair test, how to create a risk assessment, and how she can make her results accurate as possible. So you're looking at accuracy. So the answer that I've written down is that first she has to measure from the hole to the center of the mass and then pull the ruler to one side and release. So she has to now measure the time. You guys can see you have to measure how she used the apparatus. That's answering that type of question. You have to measure the time for 10 swings and repeat. You have to divide the mean time by 10 and change the position of the mass by 10. Now keep time to same point on the swing, the same to maintain a fair test. So you can mention that this point is just for the fair test part. So we have to take that. The risks involved are the stand could topple over or the ruler could hit someone. This is showing us the risk assessment of this case. And how she could make her results better is that for accuracy, she should take more than 4 values of D. D just represents the distance. In this case, it's a short form of distance. And she should use small amplitudes. So this is your answer, highlighting all these points using good English in a paragraph style. Should be a basic exemplar for all of you guys to follow and while writing these type of questions in good English. Alright, let's move on to the next question. Now, the next question states that a graph, now this is a graph question. The graph of the student's results is shown below. You guys can see that there's a time for one swing in seconds. You guys can see that there is also a distance and some kind of funny upward graph. Alright, so, okay, so you have to describe the pattern shown by the graph. So as you guys can see, as the distance increases, the time of the swings also increases. So basically you can mention that there's a reduction as well. So you can mention that there is some form of, let me just reload the system again. There is some form of initial, let's say there's some form of initial reduction in t, which is the time in t, as d increases. So d is just the distance short form. And after, let's say, if you guys can see that after about roughly about 30 centimeters somewhere here, if you guys can make a guess out of it, so roughly about 30, after 30 centimeters, value of t, which is time, increases for higher value of d. So you're just going to explain it for 2 marks. 2 points is that you're going to explain the reduction of the drop, and then you're explaining the increased part of it at 30, roughly about 30 centimeters somewhere here around. Okay, let's move on to the next question. Now the student thinks that the measurements of time for d is equal to 10 centimeters by me anomalous, so she takes a fourth measurements. Here are 4 measurements. Here are her 4 measurements. You have to state whether you consider any of these measurements to be anomalous. Justify your answer. So they seem to be okay. I mean, looking at the distance part, so her distance for measurements of time for distance is roughly about 10 centimeters. That should be alright. You guys check the others. So none of these measurements seem to be anomalous, because the fourth reading is pretty close to the mean, if you guys have noticed that. If you guys look at the table above, it's about, like, let's say roughly about 15.4. So 15.4 is the mean. If you guys look on the table above, 15.4 is the mean. So you guys can see that 15.4 is there. So what we're going to say is that no, none of these measurements are anomalous, because the reason, because 15.4 seconds, which is, let's say, which is the fourth reading, seems to be very close to the mean in the table, in the table. All right, so in the table. So now the range of data could be that 0.2s are very small, or you can say that the variation in data is expected, but it's basically no, because 15.4 seconds, which is the fourth reading, seems to be very close to the mean in the table. As I've shown you, 15.4 is there in the table as the mean. Alright, so this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below what your thoughts are about this video, and whether I should continue solving questions related to past papers or a specific topic by questions. And yeah, I think that's it. New content will be posted soon. And yeah, that's it, guys. All right, bye, guys.